All right. In today's session, I want to cover off some of the monitoring tools and monitoring features that Cloudwatch in AWS has. So when we deploy our data service and decisioning services into production, it'd be good to actually know, is it actually running well and how is it performing? How much uptime and when is it actually failing? Those kind of things. And if it does fail, it'd be great to receive some sort of notification, some sort of email. So those are all the things that kind of come along with a production system, just being assured that your application is running as designed. So I'm going to cover off on a few things today. So CloudWatch synthetics or synthetic monitoring. Also going to look at CloudWatch insights, and also kind of related to the synthetic monitoring, I'm going to quickly cover off Canary deployments. Okay, so synthetic monitoring is basically what it says here is using Amazon CloudWatch synthetics to create Canaries. So Canaries are small little applications that will just double check your API endpoints and services to make sure that they're still running and functioning as required. So basically just checking your endpoint and making sure that it's getting a 200 HTTP status code back, which indicates that it's running okay. Okay, so I'll just quickly diagram what this actually means. So let's assume, ignore this little Lambda function on the side at the moment. Let's just focus on Lambda. So you've got a Lambda function here, which is this orange circle. Then you've got a gateway or an API endpoint that sits in front of the Lambda function. And we're going to have consumers, other consumers that are going to be on our RACQ network. They're going to be going in via the gateway to hit our Lambda function to get a sort of outcome or decision or response from our service. Okay, so what happens is we want to make sure that our gateway is still up and running and that it is still passing the payloads into Lambda function and we're getting response back correctly. So what Cloudwatch has set up is I guess, a framework of Lambda functions. So that's your small application. Then it's also combined that with CloudWatch events to, on a schedule, trigger the Lambda function. And then also it's got hooks into S3 bucket just to log each time that it actually has pinged your API. So what happens, say for example, every 5 minutes, CloudWatch events will trigger, and that will fire off a Lambda function. That will go via an ENI, so Elastic Network Interface, into your gateway, and then double check that the Lambda function is working. Then it'll get a response back, and then it would log that information back down to S3. So it's all pretty integrated nicely, and it's got a whole user interface alongside it. Okay, so I'll go over, let's see. Okay, so to find that section, let me just make this a bit smaller. So it's all under application monitoring. So I've gone over some of these things previously where you can use service lens to actually see how transactions are operating and times and point-to-point integration between, say, a client Lambda function and another Lambda function, like how is it all performing? So this is a feature of X-ray when you enable X-ray on your Lambda functions. Traces is to help you look through specific transactions, and you can basically use this to filter down your CloudWatch logs. I don't actually use resource health. Haven't gotten around to using that just yet, but that looks like it's related to EC2. So we're actually not using that just yet. Okay, so the section that we're interested in is the synthetics canaries. So under application monitoring, you've got synthetics canaries, and then you've got the canaries down the bottom. Okay, so I'll just go through the process of what it might look like to create a canary. So if you click on create canary, what I've been using is a blueprint. So blueprint heartbeat monitoring. So this is when I want to just double check a single URL and just making sure that it's working correctly. Actually, you might be able to use this one. Actually, yep, this is the one that I used. Okay, so I used API Canary, monitor your APIs as HTTP requests. And so if you go down below, select a name, normally you can hook this up to HTTP APIs that are already deployed into your account. And then you've got a few blueprints already. So if you scroll at the top, I'm using blueprints. You can use other methods, so importing a script or inline editor. So if you wanted to code everything up from scratch, but if you use a blueprint, they've got a template. So API Canary, scroll down, you've got a few options. You can use Node.js or you can use Python. I've just selected Python. And you can see it's just importing JSON, an HTTP client, a URL parser. Then it's just going through the process of, where is it? Basically in this section, it's creating a connection to your URL with the various headers and then getting a response. So it's just taking this code and modifying it to your API as desired. So we would need to put in API keys and whatnot into here. And then you can see down here, the schedule. So you can either use a schedule defined every day, every X number of minutes. So 1 to 60, run once, or cron expressions. Probably easiest just to use this, the schedule. And you can tell it how long to keep the data, the logs of each of the, I guess, scheduled calls into S3. And then you have to set the permissions, making sure that your little canary has permissions to actually call the API. And then also setting all these VPC settings and Cloudwatch alarms and whatnot. So we would be setting these kind of things. So there would be an alarm to tell when there is an error on the API endpoint, and we would also be needing to set the VPC settings because all of our APIs are going to be attached to our VPC network, so only allowing internal network transfer. Okay. So I'll just go over to my application. And so this is where I'm configuring it in code. So rather than doing it via the console on the left here, we set everything up in code. So it gets deployed into CloudFormation or with CloudFormation, and it's each time it's deployed into the different environments, it's repeatable and exactly the same. So if I go down to line 719, okay. So this is using AWS CDK syntax, which is just Python implementation. And this section here, I'm creating an application canary, just giving it an ID, defining the schedule. And then here I'm defining where to find the application code for the canary. This is the runtime. So it's saying that I want to use the Python runtime basically. And then this is just defining where to store the logs in S3. Okay. So that's all done. Then I need to create a application. So this is reference to the application code, the Lambda code. And this is done here. So again, you can see I've got the JSON, HTTP client, URL parser, operating system to pull in probably some environment variables. And here again, I'm making the connection request to my API using various headers and whatnot. And I'm just getting a response and making sure it's all working. Now there's a few extra things down here. Actually, I've simplified what's done above. So I've ignored the above bit and I've just done I've passed in the string in the headers. Yep. So in this section, what I'm doing is I'm retrieving the API key. Once I've got the API key, then I'm reconstructing the header with the API key. So I've got authorization to hit the endpoint. I'm setting the method that I want to call. I'm setting up any data that I want to put into the request body. Then I'm passing that all into this function. So verify request. And then that verify request goes through this process. That was part of the blueprint previously. Okay. So once all of that has been done, then you'll end up something like this. You'll have your deployed application. So this is the Cloudwatch synthetics interface. And you can see the last run has passed over the last 24 hours. There's no issues, 7 days, 99% uptime. That's because I probably was doing some deployment activities and sometimes it failed. It's currently in a running state. This will give you all the logs of each time it passed and failed. So you can see at various points in time it was failing, probably because I was deploying something. But other than that, it's been working quite well. Now, screenshots. I don't think I've recorded any screenshots. And here you can see some metrics of the Canary. So you can see how long the Canary is taking to poll your endpoint. And it would give you an indication of any failed runs. And then you can see some kind of metrics for Lambda function itself. So the duration errors and how much it's throttling. Okay. Then you can look at configuration. It's all the same things that I configured in code. So a name, environment, when it was last modified, the IAM permissions that have been assigned to this application canary. Active tracing I've disabled. This is just the Lambda handler, so where to find the code. So it's actually under Canary handler, which is the Canary file under the handler function. This one runs every minute and it will time out after 1 minute. And this one is just keeping days for 31 days and it's telling you where to find all the information. Now, this one, it's probably, since it's been deployed using CloudFormation, it has pretty much the whole code. So it has the whole directory, whole Python directory kind of zipped up in here, but actually only references this one file. And that's why it can't show it. Okay, so that's application Canary. So what happens is There's also another alarm that's created in okay, here. So what happens is that application Canary is pinging the endpoint every minute at the moment. Then what we've done is also set up an alarm. So an alarm will basically process the results from the Canary. And so this alarm has this rule. So for every single data point within 1 minute, it'll check whether or not there is any 500 errors. If there's any 500 errors, then it would go into an alarm state. So at the moment, because all of the, I guess, status codes that are coming back are 200, then that means they're okay, that API endpoints are okay. And so that's why it's in this state. Now, what happens if it gets into an alarm state? Let me see. Can't actually find where I've referenced it, but what should happen is there's a SNS notification. Let's see if I can find this. I can't find it at the moment. Maybe I haven't set it up. But what we could do is basically you have your Canary monitoring your application every minute or 5 minutes. Then you have a Cloudwatch alarm that will trigger if there are any errors. And then if the alarm triggers, then that could send a notification to SNS. And then SNS, you could have emails attached to that SNS topic. So each time a message gets put onto SNS, so SNS is simple notification service, then all the people or all the emails that have subscribed to the SNS topic will receive notification that the endpoint has failed. I don't think I've set that up just yet at the moment, but it shouldn't be too difficult. Okay, so that was application Canaries. Now, on the Canary deployment, I wanted to also, on Canary monitoring, I wanted to go on to Canary deployment. So it kind of relies on Canary monitoring to occur or to have some traffic to be based upon. So Canary deployment is when you have a new version of your application code. So it's also known as blue-green deployments. When you want to deploy a new version of your application code, but you want to test it in production. So if you look at this diagram, you've got users or consumers. They go through the network and 95% of your users will be hitting the old version of your application. But then you also want to route 5% of your users to a newer version of your application. So this way you can test your new application on a small amount of users. And then if it fails, then you can roll back. So what we have is we have canaries basically, right? We have our canary monitoring that will keep on polling or hitting our application. And if it's hitting our application and we're doing a deployment, then 95% of our Canary monitoring checks will hit the old version, but then 5% will hit our new version. And during deployment, the deployment window will say we'll stay open for about 10 minutes. And so the Canary will be hitting and testing your newer version of your application for 10 minutes. And if it is throwing any errors, and if it's triggering a Cloudwatch alarm and then triggers the SNS topic, you could set it up in such a way that it rollbacks the deployment. So it would test your new application with 5% of the traffic coming through. If it passes correctly, then it could switch to 100% traffic going to the new version. But if it throws an error on 5% of your traffic and fails, then it could automatically roll back and then transfer 100% of the traffic back to your old version. Okay? So the way that's set up, I don't really have anything graphically nice to show, but it's part of the application stack. Then let's see. Okay, so here I'm setting up different Lambda functions, right? So I've got a Lambda function. I've given the Lambda function an ID. Then I've told it where to find the Lambda function runtime, where to find the code. And I've also enabled X-ray tracing on the Lambda function. So in addition to that, then I've also created an alias. So an alias is just like a little pointer to different versions of the Lambda function. So at deployment time, what will happen is I'll have a Lambda function deployed into production, so the old version, plus I'll have a second version of this Lambda function deployed, so that will be the new or latest version. And then you'd have the alias that would be switching between those. So even though it says latest at deployment time for the Canary deployments, it will be managing the distribution. So 95% of the traffic will be going to the old version, and then 5% will be going to the new version. And so that's the reason for the alias, to kind of manage that switching. Okay, and then to actually manage the deployment activities is using code deploy. So code deploy and then a Lambda deployment group. This is referencing which alias to use to control the traffic. And then the deployment config. So this is controlling how to manage the distribution of traffic. So when a new version of your Lambda function comes in, what do you want to do? Do you want to progressively switch the traffic over, or do you want to do it all at once? So at the moment, it's set to all at once. So the moment a new version of Lambda function is deployed, it will automatically switch 100% of the traffic over. Okay. But you could, if you really want, you could set it to a linear 10% every 1 minute. So basically you've got 100% of your traffic that comes through. So every 1 minute, I want to move 10% more of my traffic over to the new version, and I want to make sure that it's still working. So these are some of the different options that you do have. So you have all at once, Canary 10% every 15 minutes, 5 minutes. And so you can look these up to see what they actually mean. Okay. And then you are attaching the alarm. So alarms, application failure alarm. So as I said, during deployment, it will be monitoring for any errors. So it will be progressively moving the traffic over from old version to new version, and it'll also be looking for any 500 errors. If there are any 500 errors, then it would start to roll back. Okay. I won't actually show this in in this demonstration because it's kind of a bit boring to show. Next thing I wanted to talk about was Lambda Insights. Okay, so Insights. So you've got Lambda Insights here. So Lambda Insights is basically application monitoring. So monitoring the performance metrics of your Lambda functions as they are operating in production. And so if you've got your Canary application polling this API endpoint and subsequently your Lambda function every minute, then you start to get some of these metrics. So here you can see you've got either to option to look at single function or multi-function. And this is just looking at all the functions at the moment, and you can see metrics. Let's just look at a single function for now. I'm just going to look at the boat function. Okay, that one doesn't have any data right now. Okay, so here you can see just Lambda function metrics, right? So invocation errors, duration, how long it's actually taking to run the Lambda function. So this is just the Lambda function component, so not the whole end-to-end, including the API gateway endpoint. But you can see that it's taking about 100 milliseconds. Then you can see whether or not it's throttling, memory usage. So again, you pay for Lambda functions by the amount of memory and time, execution time that your Lambda function is running. So the longer that the duration is, and then the higher the memory usage is, that results in more expensive Lambda executions and billing. Then you can see the CPU usage down here. So this is all in, I think it's all in Linux metrics. I'm not sure how to interpret all of that information. This is network usage. And then you have the individual transactions, and you can see duration and whatnot. Now, I saw something before. Okay. Some other interesting thing that I saw below was when you set it to multifunction, then you can scroll down, you can see a summary of each of the functions. And then you can also see a breakdown of how much data has been passed, maximum memory, CPU time, network IO, but more importantly, cold starts. So Lambda functions are serverless platforms, but still it's serverless in the way that AWS manages all the infrastructure in the backend. So each time your application needs to be run, it needs some sort of virtual machine in the background to be stood up, and your application gets run on that machine. So there are some instances where a new machine needs to be stood up for your application to be loaded into because of various things. Let's say it could be timeout. Maybe your application hasn't been running for 15 minutes or so, and then the machine in the background has shut down because you're not using it. And then when another request comes through, say 20 minutes later, then it says, hey, there's no machine running in the background. I need a new machine. So that's kind of a cold start when it has to go through that whole boot process again to start up your virtual machine, to load up your code, and then it can actually run your application. So even though that it is running the heartbeat or Canary every 1 minute, it's still showing that at the moment there have been 3 cold starts recently. Yeah, so I guess this whole framework is well integrated back into Cloudwatch, as using Cloudwatch as a monitoring service rather than trying to build out a custom solution for monitoring and everything. Yeah, so in summary, those were some of the new features or some of the nicer features for monitoring, specifically for Lambda functions, since we're going to be building out a lot of data services, which are probably going to be, for the most part, built on top of Lambda. All right, that's it. Thanks.